So welcome to day 2 of Honors Geometry. So we're going to talk about a couple more terms today. So you'll want to put these again in your definitions section. So the first one is collinear versus non-collinear. So this may be a term you've heard before, but you've certainly heard terms like this before. So if you think about something like your coworkers are the people that work with you. They work in the same place. So collinear, if you look here, right, the root word here is line is built right into that. So what collinear means is that those points are all on the same line, just like coworkers work in the same place. So collinear might look something like this, where I can draw a straight line, again, pretend that's straight, where I can draw a line that goes through all three of those points. So these 3 points here, and I'll call them point A, point B, and point C. Points A, B, and C are all collinear. So then I hope it's obvious then that non-collinear means that the points are not all on the same line. So something like this. So I cannot draw a line, a straight line. So again, when I say line, I mean in straight. So I can't draw a line that goes through all three of those points at the same time. So these 3 points would be non-collinear, and these 3 would be collinear. And next up, we're going to talk about betweenness. So this isn't something that comes up a whole lot, but I just want to make sure that you understand in geometry what it means for something to be between something else. So if we're talking about points, here, when we say between, what we really mean is this point and this point. If I want to talk about a point that's between those two, so let's call this P and Q. If I want to talk about a point that's between those, I'm talking about something in here, or over here, or over here. All of those points would be between P and Q. And they're between P and Q because they are collinear with P and Q. So something like this out here, we don't in geometry consider that to be between P and Q because that's not collinear with P and Q. One way to check to see if a point is between other points is if I take this point right here, we'll call this M. So if M is between P and Q, in other words, if it's collinear with P and Q, that would mean that the length of PM plus the length of MQ would have to equal the length of PQ. Just a little note here about notation. Notice that I didn't put the little segment symbol above these, because in this case, I'm not actually talking about the segment PM, I'm talking about the length of PM. So when we're talking about the length of something, we leave off that little symbol above it. So this would mean segment PM, and that would be referring to the actual physical segment, as opposed to this up here, as opposed to this, without the little segment symbol above it, this indicates that you're talking about the length of PM plus the length of MQ equals the length of PQ. So we use equals when we're talking about numbers. You shouldn't ever be using an equal sign if the things on both sides of the equal sign don't represent numbers, and lengths are just numbers. If we're talking about segments, then we use that little congruent symbol that you saw in last night's homework. So you might see something like, PM congruent to whatever. So we use this little congruent symbol when we're talking about the actual shapes, when we're comparing the shapes. If we're comparing the lengths, then we're going to use equals. Okay. What would happen, think about what would happen real quick if I put point N out here. How is Pn plus NQ, fill in the blank here, related to PQ? So think about what would go in that blank. So is this side greater than this side? Is this side equal to this side? Or is this side less than this side? So to see if you can decide what goes in that blank. So hopefully you chose greater than. If I get the pen, there we go. Hopefully you chose greater than. So if you think about it, if you're going to walk directly from P to Q, the shortest distance between any 2 points is a straight line. So if I'm going to walk directly from P to Q, that straight line, this straight line right here, is the shortest distance between those 2 things. So if I'm going to go from P out to N and then from N over to Q, that distance is definitely going to be longer than just walking straight from P to Q. Which brings us to the next topic, right? The triangle inequality. So this is basically what we just said. The triangle inequality says that if I take the sum of the lengths, so if I take any 2 sides of the triangle and add their lengths together, that length has to be greater than the length of the third side. So again, think about what we just said. If I walk directly from D to G, that is going to be the shortest distance, which means that if I add up that distance plus that distance, it has to be bigger than the distance directly from D to G. And the same is true for any of the other 2 sides. Right? If I go from O to G, that's the shortest way to get there. If I go from O to D and then D to G, so if I add up this side plus this side, that's going to be a longer distance than walking directly from O to G. And then the same thing could be said for walking directly from O to D. If I go directly from O to D, that's going to be shorter than if I go from O to G and then G to D. So that's all the triangle inequality is. Hopefully, if you take a step back and think about it for a second, that should be pretty obvious, I hope. And while we're talking about properties of a triangle, I just want to mention that another property of a triangle that you're going to see come up relatively often when we're talking about triangles is that the largest angle of a triangle is always across from the largest side of a triangle. And then the smallest angle is always across from the shortest side. So in this picture, right, DG is the longest side. That means angle O is going to be the largest angle. And OG is the shortest side, which means angle D out here is going to be the smallest angle. And then obviously angle G is going to be in between those 2 measurements. Okay, so we're going to transition now into doing hopefully simple, we're going to transition into doing some proofs. Proofs are a big part of this course, and really all proofs are really just practice in making a logical argument. So I just want to talk about things you can and cannot assume from looking at a diagram so that we don't make mistakes in assuming things that we're not allowed to. So some things that you are allowed to assume from a diagram is that if something looks like a straight line, it is a straight line. So for example, in this picture, it's okay to assume that BCE is a straight line. Though you may see, again, when we get to the Regents exam, they will probably give you something like this in their list of givens. So a given is just something that you're told is true, and therefore you can go ahead and accept that fact that it is true. So you may see something like this, where it says given, and then they'll do something like this, BCE, segment BCE. And all that really is doing is confirming that, in fact, BCE is that BC and E are all collinear. What else? So you can assume things that look straight are straight. For our purposes, you can assume that things that look collinear are collinear. So for the questions I write, you're not going to see me write this as a given. On the Regents exam, they will. But for our purposes, it's fine with me if you just assume BC and E look like they're on a straight line. Let's assume that they are. And then things you can't assume. Don't assume from a picture that one side may be bigger or smaller than another side, because the picture may not be drawn to scale. You shouldn't assume that segments are congruent just because they look like they are. You should not assume that angles are right angles just because they look like they are. It certainly looks like angle D is a right angle. It certainly looks like angle A is a right angle. But unless you're given a piece of information or can prove other things are happening, you can't not make the assumption that those are right angles. All right, so now let's look at some more definitions. Again, you're going to want to keep these in their own section because when we get to doing proofs, it's going to be really, really helpful for you to just have a single place to look for all of your definitions and theorems that you're going to use when we do proofs. This is where you're going to go when you're looking for a reason to justify a statement. So in a proof, what you're going to do is you're going to make a claim, and then you're going to give a reason why that claim is true. And all of the reasons that you're going to give are going to come from this definitions, and ultimately when we get to, we'll also have theorems in here as well. So make sure you have these separate in a separate section because that's really going to be beneficial to you later on. So the first one we're going to talk about is what is a midpoint. So a midpoint is something that divides a segment, not a line, a segment into two congruent segments. So remember this little symbol here means congruent. So right, that little symbol there means congruent. I think I can even read that. So if you're told that something's a midpoint, a conclusion you can draw from that is that the two segments are congruent. So if you're told that B is the midpoint of AC, what that will allow you to do is say that AB, segment AB, is congruent to segment BC. So again, I'm using that congruent symbol because I'm talking about the shape, the actual segment AB. It would also mean, by the way, that the length of AB is equal to the length of BC. But in proofs, we don't typically talk about the numerical values. We typically just talk about the congruency or how the shapes compare. And then similarly for an angle bisector, an angle bisector is the equivalent to a midpoint except for an angle. So an angle bisector will take a larger angle and divide it into two congruent angles. So that's what this is. An angle bisector divides an angle into two congruent angles. So we mark angles are congruent by this little symbol right here. By the way, we mark segments congruent by this symbol, or, I mean, really you have to mark them with the same symbol. So if I wanted to mark two segments congruent, let's see if I can do this somewhere else in the page. If I wanted to mark two segments congruent in a picture, I could do this. So I could say that is congruent to that. So as long as you're marking them with the same symbol, sometimes you'll even see this. I think the textbook uses things like this. They'll put like a little circle on both. Or they might put a little triangle on both. So you can decide how you want it. I'm partial to these kind of symbols. So you could do one hash mark, you could do three. Beyond 3 or 4, it kind of gets a little excessive, so you feel free to use a different symbol if you want. But really the key is, if you see them marked with the same symbol, that means that they're congruent. And then for angles, the way you would mark them congruent is, so if I said this angle here, and I divided it in half. So I could mark it with one thing, I could do two. So again, as long as they have the same symbol on them, so you could even do something like this, where you do this, and then say, okay, circle and circle. So you're just marking them with the same symbol to indicate that they are in fact congruent. And then a couple other things. These don't come up very much in proofs because you don't usually have angles that are, segments or angles that are trisected. But just so we understand what it means, a segment trisector divides a segment into actually 3 congruent segments. So this right here, right, that would mean segment AC is trisected if AB, so in this case AB is congruent to BD is congruent to DC. And so you can tell that on the picture because they're all labeled with the same symbol. And again, I want to just make sure we understand that I'm talking about the segment being trisected. You can't trisect a line. A line has infinite length. You can't divide something of infinite length into 3 equal pieces. Same thing with dividing it into 2 equal pieces. You can't bisect a line. You can only bisect segments. You could also not bisect array. The only things you can bisect and trisect and cut into equal pieces are things that are finite in length. So that's just segments. And then the last one is an angle trisector. So similar to the angle bisector, an angle trisector divides the larger angle into 3 congruent angles. So again, these are all marked with the same symbol, so that's indicative that those three angles are congruent to one another. Okay. Another word that you're going to see quite a bit is perpendicular. Perpendicular means that you've got some lines or rays or segments or any combination of those things that meet at a right angle. So here's an example. We've got two rays that meet at a right angle. We've got two lines that meet at a right angle. You might have a segment and a line here that meet at a right angle. And the symbol for this is an upside down T. So that's the symbol for perpendicular. Now keep in mind the symbol makes it look like this is always in the middle. So based on the symbol, it might seem like this is cutting this and this segment's getting cut in half, but it's not necessarily getting cut in half. So if you think about like this picture, this is perpendicular to this. So if I call that line L and this line M, I could say that line L is perpendicular to line M. But again, this symbol does not mean that M is in any way getting cut in half, which it can't get cut in half because it's a line. But even if it were a segment like down here, so if this were segment AB and this were line Q, we could say that Q is perpendicular to segment AB. But again, it does not mean this symbol, just because the symbol happens to be right in the middle, does not mean that it's also cutting it in half or bisecting it. So that's important to note as well. All right, so let's take a look at an example. So here's your list of givens. So there's these two right here. So again, given just means this is information. You just have to accept that it's true. So even if the picture doesn't look like it's true, if it says it's true, then it's true. So here we're given that ray KJ is perpendicular to ray KM. So that means that this angle right here is a right angle. So if you wanted to, and I would suggest getting in the habit of doing this, when you see something that's a given, if you can mark something on your picture that corresponds to that piece of information, go ahead and do that. So in this case, that means I would put a little right angle symbol right here, because that's what that given piece of information means to me. And having a labeled picture is going to be really, really helpful for solving problems and doing proofs. So we also know that angle JKO, so this angle right here, so remember the vertex is always the middle letter, so that this angle right here is 4 times the length, or the measure, not the length, the 4 times the measure of this angle right here. So remember that little m means the measure of angle JKO is 4 times the measure of angle MKO. So the question here is, what is the measure of angle JKO? So why don't you go ahead and give that a shot, and then we'll come back and see how you did. All right, so this is one of those cases where you've got to be careful because the picture does not match what the given information appears to tell us, or does tell us. So the picture is not drawn to scale. So we know that angle JK, the measure of angle JKO, so this angle here, is 4 times the measure of this angle. So I'm going to call this one X. You could use any symbol you want. You can use a happy face, you can use a star, whatever symbol you want. X is a very common one to use, so you'll see me use that a lot, but know that you could really use any symbol here. It's just a placeholder. So if I call this one X, I know that this angle up here is 4 times that. And then from my given information, if I know that they're perpendicular, that means that they're right angles. And as we discussed yesterday, or I guess it was 2 days ago now, if something is a right angle, that means it's 90 degrees. So here's the equation I'm going to write. I solve this and I get x equals 18. And then I go back and make sure I answer the question, which asked me to find the measure of angle JKO, which would be 18 times 4, which is 72 degrees. So you probably want to get in the habit of putting the units on there. For this course, we're just going to measure angles in degrees, at least for now. We may or may not get to talk about radians. We'll see what kind of time we have. But for right now, we're going to talk about the angles and angle measures in degrees. All right, so that's the first half of our lesson today. So from here on out, because we're doing double periods, each day we're actually going to be doing 2 lessons. So this would be really equivalent to 1 day's lesson. And I'm going to cut the video here and make a new video for lesson 2 so that you can take a break in between if you need to.